let's do 101 here, which is computer vision. And all these projects are using standard machine learning data that's available on the internet. So here's a Fashion MNIST data set of a bunch of little grayscale pictures of clothing items that are in 10 categories. And here's the categories, things like t-shirts and dress and sneaker and bag. So, and they are labeled. So this is a supervised training task. And here's how it works. So we feed in 784 values, which is 28 by 28 pixels. Each one goes from 0 to 255. So all that is the X values. Then you need a more complicated neural network here. And here's what it's going to look like. In comes the input image, and just the layout of the Python code for this. It doesn't like taking a two-dimensional input. It wants just a line of pixels. So you get 784 pixels. By the way, notice it therefore doesn't know the shape of the image, and it doesn't know which pixels are near other pixels or anything. It's going to have to figure out all that from training. Then it goes into layers of hidden neurons, and then those get into 10 output neurons. And those are going to be the probability that it is in the category coat or sneaker or bag or whatever the other categories are. So here's how you train the neural network. And you'll see it's really pretty easy to see. This is using this Keras. These are the models. And so the first one flattens 28 by 28 down to 28 times 28 flat neurons in a row. Then this is the hidden layer with 128 neurons. And here's the output layer with 10 neurons. So all this is doing is having one hidden layer with 128 neurons that's going to do all the work. And then it's going to just, we'll learn more about these later, use an optimizing scheme and a way of measuring loss, and it's going to fit the model. So let's run this and see how it looks. All right. So here it is connecting. It spends maybe 10 seconds connecting and allocating resources. I think it's just loading up a virtual machine or a container. I'm not sure exactly how it works. And here we go. Now it's downloading data from Fashion MNIST. Here it splits it into training and test images. So you have, I think, 80% of it used for training and the remaining 20% held back for testing. And here it is running the first epoch of 5 epochs. Each epoch is going to take about 10 seconds because it's using a lot of data and processing. And so here's the loss and the accuracy. So the loss is going down and the accuracy is going up. And 82% correct, 86% correct. %, so it goes up.
So what is it doing between epochs?
It is taking a step. It uses a technique called reverse mode auto diff to calculate the slope in the high dimensional space to figure out which direction would improve things, and it takes a step in that direction. So it's just adjusting the parameters in a way to improve the model. And it measures these loss and accuracy numbers, and these are on the test data. And then it should be doing the evaluate. It's doing the fit. Then when it's done doing fit, it's going to go to evaluate, and then it's going to test it on the test images, which it has never seen before. So it's training. Yeah, now it's done. Now it went to the test images, and so the accuracy on the test images, so it got up to 89% correct on the training images, but it's only 86.5% correct on the test images, and this is what you expect. You expect it to be a little less accurate on arbitrary new images than it was on the ones it's been training on. And don't know what those numbers coming out there are. Don't know. Didn't. Anyway, so let me see if I saved myself a tip about those extra 2 numbers. I may not have. Nope. All right. Anyway. All right. So now we can look at the results for images to see why it's making mistakes, because it only got up to like 86% correct, so it's making quite a few mistakes. And we can try to understand why it's making those mistakes. So this is going to just print the first 20 outputs of the model. So what this is, the first number is the right answer. And then each number is the percentage of it being in each of those categories, 0 through 9. So the first one should be a 9, and it had a 95% chance of being 9, so the model worked. 99, 99, wherever you see 99 or 100 or something like that, it worked. This is one it's getting confused on. It should be a 6, 0, 1, 2, 3, 4, 5, 6, and it did decide it was a 6, but it had a pretty high chance of being a 0 as well. Here's one, 49, 49, where it was either a 3, 0, 1, 2, a 2 or a 4. So it's confused about that one. And that looks like the main one. So let's make sure and check this one out. This one here it seemed to be confused about. So let me figure out which one that is. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. 10 or 11. 3, 6, 9. It's number 11. Yeah, it usually gets number 11 wrong. And so after I found one it got wrong, we're going to view the images and make sure and see one that got wrong. And as you see, in my example, it was 11. It's not always 11 it gets wrong, but in this case, it got 0 right, and it got number 11 wrong, so we can compare a right and wrong image here to understand what it's doing. But don't want to do that. All right. All right, and so this one is number 0, and it got this one right, but this one it got wrong. And as you can see, this one, it was confused about whether it was a 2 or a 4. And if you look at what those are, 2 and 4 are pullover and coat. Well, I'm a little confused about that. Anyway, I think I've lost the counting somewhere, but what it really is confusing is like 2 different kinds of shoe. It's sandal or sneaker are the 2 categories it was confused about here. And I'm not quite sure why I'm getting it confused in my live one. I'm probably printing the wrong image or something. But anyway, then you can get some idea what it's doing and why it's getting things wrong. And if you train it for more training epochs, then what it'll do is it will improve the accuracy here. Remember, it's only up to like 86%. It's going to get up to 93%. But when you run it on the test data, it's only going up to 88. So the additional training is making it fit the training data better, but not the test data. So what you're doing is overtraining. Now you're fitting not only the signal, but also the noise. You're not actually improving the model here. And so there's a flag defined there, so you get to see how it works. And that's the simplest image processing project. So I'll stop this one.